Dear aspirants, welcome to my channel. This is an model question paper, Civil Engineering, third semester, C25 syllabus. C25 syllabus. Name is Advanced Surveying. Subject code is 25CE31I. Okay. Now we are going to learn part B, 2 marks question and answer you are going to learn now. List two temporary adjustment of transite theodolite. Okay. Here, if you want to do the temporary adjustment, first you have to do centering, next you have to do leveling, and third one we have to do focusing or elimination of parallaxy. This you can write it. If you want me to write the sentence, you can write. So centering nothing but you have to keep the theodolite exactly over the station point. That is, we call it as in centering. So coming to the leveling, we have to adjust the instrument exactly in the horizontal position with the help of foot screws. Next, differentiate between face left and face right observation. So very simple way I'll tell you. In the face left observation is, in the theodolite you have a vertical circle. Vertical circle left side of the telescope, that we call it as a face left observation. Okay. So here the vertical circle on a left side of the observer while taking the reading. It should be left side. And it is also, you can see when the vertical circle is left, that time the telescope should be as usual position. It's a normal position. Coming to in the face right observation, same, if the vertical circle right of the telescope while taking the reading, means whenever you see the reading, you just see in the instrument, it should be right. Vertical circle will be there, that should be right of the telescope, that is face right observation. When it is an face right observation, that time you have to see the telescope. Telescope should be reverse position, nothing but you can rotate the instrument 180 degree. Reverse position nothing but you have to rotate the theodolite in a 180 degree. Next, define closing error or a close traverse. How it should be determined. The closing error nothing but when you start the survey here, so it will be a one circuit loop. So some error will be takes place. This we call it as in closing earth. We represent E. It is a point A, point B, point C, point D, point E. Error should be point E. Error should be. It means the definition. Coming to the definition. So where you can write a difference between the computing closing point and actual starting point of the closed traverse. Nothing but when you start the point and again if we enter into the same point, is a small distance, that we call it as an closing error. This error may be with the help of an angle or with the help of the distance, based on the distance and angle. Okay, that we call it as in closing. So how we are going to determine? We have to calculate sum of the latitude and departures. So sum of the latitude north direction, departure nothing but east and west directions values. And in that, if the sum is not equal, so we have to go for the difference in the error. Sum always will be equal. Horizontal and vertical always will be equal. If not proper, you have to go for it is having a error. How do you define closed perfect traverse? Nothing but summation of north is equal to summation of the south. Summation of the east is equal to summation of the west will be equal. Next is list the component of or segments of geographical position system. Now GPS nothing but geographical position system. So first will be in a space segment. Okay, space segment, what you will get? It consisting of GPS satellite overall the earth, orbiting the earth surface, that is space segment. So coming to the control segment, it should be controlled of the ground, whatever will be there in the monitoring control station, that will be monitoring and manage the stations. So overall picture or overall ground control, it will be in control segment. Coming to the user segment, it is a user segment. We are using GPS system. So we will get the information where the position will be takes place, that you can determine by the user segment. Next, explain any two application of remote sensing in civil engineering projects. So in the remote sensing, how will be affected? First, coming to the first application will be in selection of the site selection. In that site selection, how you are going to determine the remote sensing? We can identify, we can suitable locate dams, highways, bridges, buildings to analyze the land, terrain, and soil condition. That sets it will be helpful in the remote sensing. Okay, it will give the proper detail about the site where we have to construct, what type of the material will be there, what type of the ground will be there, it should be determined. Next will be in route alignment, making a highways under route alignment. That so coming to the route alignment, if you see the remote sensing, it will give the best alignment of the road, railways, canals, pipelines based on study of the topography and natural obstacle. It will give the proper information by using road surveying. So, and also we can use it for urban planning, land use, land covers, we can use mappings for flood and disaster management, we can use remote sensing, environmental monitoring, watershed management, these we can use remote sensing. Next is mention remote sensing platforms with a suitable example. So first one is a ground based platform. So ground based platform, nothing but they are going to keep the camera on a tripod or tower. For example, so if you want to survey, if you want to the survey, they are going to keep the camera to watch the particular tower. Next, airborne platform. So airborne platform, we have they were using a sensor mounted on aircraft or helicopters. They are going to keep the sensor. For you can give an example for drone or aeroplane. Next will be space-borne platform, that will be a sensor-mounted satellite. It will be ready to sensor ISR, Landsat will be in sensors they are going to. So now we have to define spatial data or attribute data in GIS, Geographical Information System. So spatial data, nothing but this data which will be representation of the location, shape, position of the ground features on Earth surface by using some coordinates points, that we call it as in spatial data. So it will give the all information about the geographical features and of the Earth coordinates. It may be location, it may be shape, it may be position. So coming to an attribute data, this will give a brief introduction about information of the spatial features like name, type, area, population, other properties. It will give the proper detail about particular areas. Next, coming to an example, spatial data, it will give the location of the road or building of the map. Attribute data, it will give the road name, road width, and building height. It will give, this is the example. Next, state any two application of the drone technology in civil engineering. So, what are the applications? So, coming first is land surveying and mapping. So, if you use the drone, that will be give the proper topography of map and survey large area. We can give a survey, we can large area, they are going to give the proper information. So, coming next will be an construction site monitoring. If you use the drones monitoring, it will give the project progress and spec structures and track the constructive. And for more information, we can use it for volume estimation of the earthworks and bridge and building inspection, route planning, disaster assessment, and damaging inspection. These are the data it will be give. It will be give. If the content is useful, please subscribe my channel, share and support. Thank you.